So, Jim, what is the dirty secret in the world of AI today? We covered a bit about failures, right? And failures of digital transformation. Hi, everyone. Welcome to Ripik.AI's podcast on the future of AI. I am Pinak, founder and CEO of Ripik. With us today, we have a very special gentleman, Jim Hendrickson. Jim, what a privilege to have you here today with us.
Sure. Thank you, Pinak. It's a pleasure to be here today. I spent just under 35 years in the steel industry, focusing primarily on process automation and optimizing the process through the use of automation. I started as a process control engineer and finished my career with a fully integrated steel company as a director of automation.
Today, as we sit in March 2025, indeed we are in super exciting times. In fact, many people believe that last 2 years have seen as much change that has happened in last 2 decades in the world of digitalization. What do you think about it?
Well, certainly digitalization is beginning to transform the steel industry and manufacturing in general. Before we dig into that, let me just step back a little bit. So I've had the opportunity to witness the evolution of steel production for decades, as you mentioned. From some cases going from manual operations to automated operations, going from analog controls to digital controls. And then, just now in recent years, we're starting to move more towards the advanced control systems, which includes the use of digitalization technologies. Though not fully embraced by the steel industry, the value in these are starting to come through with the success cases that companies have had. And I think we're at the beginning of where we're going to see this technology really kind of start to transform the industry.
What are some of the real challenges or the real pain points that you have seen AI to help, or some of the new technologies to help in industrial settings more broadly?
Yeah, let me cover, Panak, what some of the key challenges are in the steel industry. And these challenges haven't really changed over time, but I think the solutions probably could be changing. So safety of our workers. Safety is always priority one. How do we ensure our workers are safe? And the steel industry is a hazard environment, but it can be made safe. So there's, what can we do to improve that? Protection of our equipment. Similar to protecting people, we need to protect our equipment and not have failures that would damage equipment. Environmental compliance, reducing emissions. We need to stay ahead of ever increasing regulation requirements. These are challenges that have always been there. Product quality, creating a product that meets the customer's requirements the first time without producing reject material. Meeting production requirements. There's always a challenge to produce more and more material. So how do we optimize our process to maximize output without sacrificing some of the other challenges I already mentioned? Optimizing energy consumption. The steel manufacturing process is an energy-intensive operation. And one of the best ways to contribute to the bottom line is to reduce our energy consumption. Increasing mill availability. Unplanned failures of equipment. Not that you ever plan for equipment to fail, right? But failures cause unplanned downtime. Unplanned downtime is very costly as opposed to planning to repair something or recondition something before it fails. And overall, improving operation efficiencies. One of the other more expensive costs of the steel industry is manpower. Energy is a huge cost, so is manpower in a steel plant. So how can we automate tasks and reduce manpower requirements? I think those are some of the key challenges. They've always been there, but I truly believe that some of the technologies that are available today are going to help us better attack these challenges.
That's a very, very interesting point, right? I mean, the steel making process hasn't fundamentally changed in the last 100 years. But you mentioned about some of the new technologies and how they can possibly enable a faster resolution of some of the problems. Can you go a bit deeper into that and share more on how some of the current technologies are more, I would say, efficient in achieving some of those end goals and solving some of those challenges?
Yeah, certainly, and this is probably where AI comes in, and AI in maybe different forms. Can we use, our control systems are pretty good at controlling the process as it was sat when we originally tuned it, set it up, right? But conditions change. The products were changed. The conditions of the equipment change, right? And so we constantly have to retune these loops to optimize production. I think we can, at some point in time, use AI to monitor these types of conditions and make these changes dynamically and not depend on someone they're constantly tuning things. Vision AI, Vision AI is a huge one. And let me reflect back over my career, especially the last 20, 25 years. The operations demand for having video in their plants is just it's grown exponentially and continues to grow exponentially. So all these facilities have multiple camera systems, and these camera systems are going into video capture systems. And if there's a problem, a safety incident, people go back and review those videos, right? If there's an equipment failure, if there's a problem producing a particular product, go back and look at that. But I think I saw a statistic recently. It said only 1% of that data from those camera systems is actually analyzed. I think 1% is high, way higher estimate than it really is. Most of that data sits on a server and is never looked at, but yet there's a lot of valuable information there. Information, if we had operators constantly viewing those cameras, they might be able to make decisions to improve the process. But in today's day and age, we don't necessarily need an operator to be the ones to evaluate that. We can actually do that more efficiently with a Vision AI system. So I truly, and so Vision AI is the one I truly believe it's ripe, it's ready to go, it's proven, and scalable.
So, Jim, I think one of the ironical things, one of the irony is that we always wanted AI to wash the dishes while we write poetry, not the other way around. What do you think?
That's hilarious. It is the other way around, and you know what? We're probably benefiting it from being the other way around. I'll tell you what, if I use AI to write poetry to give to my wife and let the AI do that and I wash the dishes, I'm a hero at the end of the night.
Fantastic. Do you think it is more hype than actual reality and more hype than substance on all the AI that is around us?
Well, that's a great question, and the answer that a lot of people give has changed, from time to time. Certainly, when these technologies were first presented to the steel industry, there was a lot of concern that it was really hype, and everybody was gung ho, ready to go. And quite honestly, those that quickly adapted, they learned a lot by making a lot of mistakes, honestly. And so the hype kind of started to die down a little bit at that point. But through continuous experimenting and doing different projects and trying this and trying that, and selecting the right suppliers to work with, we began to see some success cases, and success cases that were able to see be used over and over again. I had the opportunity to with before working for Cleveland Cliffs, I worked for ArcelorMittal in a global environment, and we had a very good group focused on studying these technologies, developing the proof of concepts. And like I said, we had a lot of failures, but we started to have success cases, and that was really exciting. So I think we had a lot of hype. To answer your question, things back down some, but I think now we're starting to see these technologies are a new tool in our toolbox, and where old approaches couldn't solve these old control solutions couldn't solve these problems. These new solutions are a new tool that we can use.
So, Jim, what is the dirty secret in the world of AI today?
All these technologies have been around forever. We want to talk about Vision AI. the steel plants have been using Vision AI for decades. It's been in more controlled environments, surface inspection systems, right? Special cameras, special lighting, this and that. But the analytics have always been there. Without question, the reason that we're here today is because the technology to support these solutions has become less more cost effective, more computing power, GPUs. That's what's driving all this. But yeah, none of this is new stuff.
So, Jim, I think in the different forms of AI which are there, where would you place, say, a vision AI versus auditory AI versus machine learning?
Well, let me. I'll answer. It's a great question, Pinak. Let me answer it in a couple different ways. So, a majority of these video systems have been put in. They've been put in to be analyzed by humans, right? By operators looking at this data and analyzing it to determine what happened. Now, so that's how most of the data has been used. Now, we have done some systems where we're using some form of vision. In recent years, historically, it was done by our internal people working in automation groups. But that took a lot of effort to analyze this data. This is that like 1% that I'm talking about. The people analysis can't even come close to analyzing, more than 1% of the data. And it takes a lot of people. But we've done these systems internally, but they take a huge amount of time and a lot of effort to get them tuned because they're really customized for our specific applications. I think nowadays the opportunity is there to apply commercial solutions, right? Where suppliers have developed these high-powered AI models, multi-level AI models to analyze these problems or these images and come up with data information about what's happening and provide that to the operators so we can make real-time decisions. So I believe that is the one technology that is ready to go right now, and we need to take advantage of it.
So, Jim, I think one of the biggest problems of a commodity industry is that the cyclical nature of it, right? Sometimes the prices are 25% up, sometimes they're 25% down. So how should one think about it? How should one think about digital spending in that context, in that variability?
Well, Pinak, that's been a challenge for the steel industry as long as I've worked in it. It's been a challenge before I worked in the steel industry, and it'll probably be a challenge coming out of it. So business cycles, they're going to come and they're going to go. We're going to see highs, we're going to see lows, we're going to see very high highs, we're going to see very low lows. Now, the challenge with that is when prices are up, demand is up. You want to produce, get the steel out the door, make top dollar. So you don't want to take the time to shut down and do improvements to your process, right? But you have the money to do it then. And when times are when prices are down and you're in a bottom cycle, steel companies want to conserve, so you don't want to spend the money. So then the question is, when do you spend the money, right? So I think the more successful way to approach that is you've got to look at, this is a cyclical company, environment, manufacturing segment. You're going to see the ups and downs. You need to look beyond those and know you're going to come out of that. And when business is low, you can't stop. When prices are low and production's down, you can't stop investing in your facilities. That's probably the most opportune time to invest. So you're ready and you're prepared to go when business picks up again. So when you're laying out your digitalization plan, it's no different. It has to be a continuous investment, and you need to look at those opportunities and make continuous investments. It's not something you can do in cycle with business cycles.
I don't want you to get into trouble. I don't want to put you in trouble, but you see, like, we are in a world where there's a lot of geopolitical changes and turbulence there might be across the world. How do you think is that impacting the steel industry, and how long do you foresee this current turbulence to continue?
Yeah, we've seen some positive movement in hot rolled pricing or all steel pricing, but I have a more tendency to follow hot roll pricing. But we're back up in price ranges where steel plants should have pretty decent profit margins, right? Certainly in early through most of last year, steel prices were pressed pretty hard, so spending was pretty tight. But I think we're looks like we're coming out of that cycle, and certainly the steel tariffs in the U.S. should bolster the steel prices in the U.S. and the profits of the steel companies in the United States would be my prediction. But it's also going to put a more of a challenge on other countries to make profits and sell their steels to the United States. So there's a lot of dynamics there, and if I knew all the answers, like I said, I'd be looking very heavily in investing or shorting in the stock market.
Fantastic. And you mentioned about failures. One common quote which I recently heard from someone: more pilots in a Fortune 100 company than what you will find in a Lufthansa. Why do you think pilots do not scale? Why do you think people are stuck in the pilot purgatory?
Pinak, that is the case in many places. A proof of concept and a pilot are two different things. And when you're referring to all these pilot projects, they're not pilot projects for the customer thinks it's a proof of concept, right? They want you to prove that technology works for them, right? We're a company like Ripik. They know this works. They've done it elsewhere, but they're asking to do. The customer wants a pilot, a proof of concept for them to prove the technology for them. But once that project is in, we see the return on investment. We should be able to move very quickly from a pilot stage to deployment and rolling out in multiple situations. So I believe we should be at the point where these companies should be moving more from pilots to rollouts. But everybody's going to want a pilot first. That's their proof of concept.
And one of the key ingredients or the requirements for a company to move fast on scale up is adoption. Right? It's real proof that the value has delivered. Now, you have seen like hundreds of this pilot, right? In your experience, what are some of the learnings which separated the successful ones from the not so successful ones?
Well, I did touch on that already, and I think the success cases we've had have come from suppliers that understand the industry. They understand the challenges in the environments that they need to work in, that their equipment is going to work in that environment. And maybe some specific challenges of the operation itself. So I think if we have a supplier that understands the steel industry, understands that the environmental challenges we're going to deal with, they come in better prepared. And we can better work with them and communicate with them. And I think that's where we have better successes.
And just to segue from that into a different world, which is you have led large automation teams, large teams of automation in several very large steel companies. Now, one question that every large enterprise today is grappling with is the make versus buy problem. What to make internally and what to buy from a vendor. In your roles over the last 2 decades, spearheading some of these technology and digital teams, what were some of the guiding principles or framework that you used for making the decision?
Yeah, Pinak, that's another great question and another maybe complex one to answer. Certainly, my desire, if I had my dream world as an automation manager at a steel plant, I would want to have the engineers to do everything in-house, right? We have full control. We can modify things as we go, but that's one luxury I don't have. I never had the luxury to have this massive automation team. And one of the reasons that's very inefficient is because I want to develop one specific solution. Say I want to put in a vision system to analyze welds on a welder to determine if I'm making good welds or bad welds. Well, I can only deploy that at a handful of places, right? So it takes a lot of energy, a lot of manpower to develop that, get it tuned right, and then so I'm only going to deploy it in a few places, right? So I'm not as efficient as a vendor that maybe will make something like that and deploy it hundreds, if not thousands of times, over and over again. So it's a lot more efficient. So, the question that you have to have a balance there. And my automation engineers should really focus on the things where you really have to have in-depth process knowledge to be able to work on those systems. These systems, but likewise, when I partner with an automation company, where I'm going to purchase something from a company, I want a company that has a background in steel. Because we've done a lot of failed digitalization proof of concepts that have failed just because we're working with a data company, a company that says, yeah, we understand big data, we can analyze your problem, we don't need to understand your process. Well, we found that if we're partnering with those types of things with a company that does understand the steelmaking process, our projects are going to be much more successful. So if we find those partners, they can do it more efficiently than we can, then we want to partner with a vendor on something.
So Jim, I think what is the typical ROI that you would expect from a successful AI deployment?
Another challenging question, Pinak. You have all these great questions. And I think that depends from time to time on the business environment, right? What's the economic environment? There are certainly times where we're looking for returns of, say 3 months or less. And, when business is great, we could probably go much longer than that. We could probably go with a 12-month ROI.
And one common question that we often get is the variability of a deployment of AI in, say, an India versus a Europe versus a US. Now, you have had the exposure of knowing what's going on in steel plants globally. How would you characterize the differences that a geography brings into play?
Yeah, so I've seen different things, and some cultures are a little bit different than others. In some countries, you'll see more of your manufacturing plants operated like that. At least at the highest levels, they're accountants. Quite often, many times they're people that understand the operation, but rarely are these people technology leaders, right? And in some environments where I've seen these projects be more successful is where you had the full support from the highest level at a plant, and that general manager at the plant has a technical background. He understands the benefits that this technology will bring. So I think that's a big part of why you see more deployment in some regions than you do others, is the culture in the way these facilities, operations, these companies grow their plant leadership.
And I think a segue from that, which is when people are doing a scale up, what are some of the signals or the early warning signals that a plant team or a leadership or a management can pick up to really assess if a solution is working or not?
Well, it's interesting. In my years working in automation, I've spent a lot of time in the working with operators. Right, these are skilled operators, been out there doing things for years, and generally speaking, they don't want you to automate their tasks, right? And so when you did something good and it made their life easier, right? And maybe it was even ultimately going to eliminate their position, but then they were going to have the opportunity to go take a more technical, advanced position in the plant, helping maintain some of these systems, right? It's when you get the buy-in and support from the people on the plant floor. When you got the operators saying, this is really helping us, it's when you see that support from the plant floor that's the positive sign that we're going in the right direction. We're going to be successful because we have the support from the people on the floor. When we've got the people on the floor saying the opposite, right? This is making my life harder. I'm having to do, intervene this way to solve problems because, it's not doing the right thing or that. That's an indication that, maybe we're going the wrong direction here and we're going to struggle to get where we need to go. But you got to have the buy-in, from the people on the plant floor.
So, Jim, I think we covered a bit about failures, right? And failures of digital transformation. Uh, can you share one failure story of such a project where you didn't receive the gains that you thought?
Well, unfortunately, Pinak, I could probably give you many examples of that. I'm going to allude to one without providing too much information here, but we had a project where we were going to we had a supplier that said they could come in and they could analyze what what one of our operators does. And we got good operators, bad operators. Just come in, take notes, figure out what they do, collect all this data from this processing line, and then take all that back and run it through their big data analytics and and provide us a system that is going to be able to make decisions based on the same data the operators do to improve our process and initially get all the operators to make the best decisions and ultimately get to the point where we're replace the operators, and we do that automatically. But unfortunately, the supplier we chose for this had all these great promises and all that, but at the end of the day, they didn't understand the process at all. And without understanding that, they were going off in just wrong directions and consuming more of our time than was ever imagined. And so, we've had several projects like that, and ultimately, in the end, we had to pull the plug on them just because we knew we weren't going to get the benefits, and we were investing too much of our time to try and get the vendor where they needed to be.
And we are today like in the early part of the year, right? We are just closing to the end of the first quarter. A lot of teams are today doing budgeting and planning for the course of this year, and every year there is usually a huge budgeting and planning exercise on which digital and AI interventions to take. For the course of this year, what would you recommend if someone if a plant has $100,000 of a digitalization budget? Which areas you feel is it best devoted to and why?
So it's a very good question. It's very tough to get those dollars, but when you get them, you want to spend them right, and you want to have the success cases. And this kind of goes back to what we were talking about earlier on Vision AI systems. Vision AI systems can be commissioned relatively quickly, right? So you can put one of these systems in, and you're going to see the return, the benefit, in some cases immediately. Another area that you got to focus on, you may not see the return in dollars today, but you'll see it in the long run. And those are systems that are going to improve the safety of our workforce. Anything that we can do to prevent an injury or a lost workday injury, or the worst case is a fatality, is that's going to be the best money you can spend. So I think that there's a lot of opportunities to deploy these vision systems. I think they're cost effective and you can ramp them up very quickly. I believe safety is a good place. I believe equipment reliability, and certainly if you can apply systems that can analyze the process and help improve energy consumption, those are huge paybacks. So I think if I was still working for a steel company, those are the things that I would focus on.
If you had to give a piece of advice to a digital leader in any enterprise, Fortune 500 enterprise, what would it be on how to harness the real value of AI or digital in today's world?
I think a digitalization leader needs to understand the technologies, understand the capabilities, share that information with the real problem solvers out there in the facility, and introduce to those problem solvers out in the operations that this is a tool in your toolbox that can help you solve your problems. If they approach it that we have a technology and we need to find problems to use that technology, and we're pushing the technology down, that's not a success. That's more difficult, and you're going to have more challenges in being successful. Basically, you want to educate people on the tools and let them know that's a new tool in your toolbox. And when conventional methods don't solve your problems, we really need to consider these advanced technologies.
So thanks a lot. Thanks a lot, Jim, for those kind words. It has been an incredible privilege for us to have you advising us in different facets. And thanks a lot for your time today. Wish you a great day.
Hey, thank you, Pinak. It was my pleasure to have this chat with you.